Let's solve this particle motion problem step by step. We have a particle p that starts at point O when time equals 0, and its velocity is given by 3 sine of 2t. Let's first visualize the velocity function. Here's a graph of v equals 3 sine of 2t. The particle's velocity oscillates between positive 3 and negative 3 meters per second. For part A, we need to find when the velocity first equals 0 after leaving O. Setting 3 sine of 2t equal to 0, we get sine of 2t equals 0. The general solution is 2t equals n pi, where n is an integer. Solving for t, we get t equals n pi over 2. Since we want the first 0 after t equals 0, n must equal 1. Therefore, t equals pi over 2 seconds. For part B, we need to find the displacement. To find displacement, we integrate velocity with respect to time. That's the integral of 3 sine of 2t dt. Using integration by parts, we get negative 3 over 2 cosine of 2t plus c. To find c, we use the initial condition at t equals 0. S equals 0 since the particle starts at O. Plugging in t equals 0. 0 equals negative 3 over 2 cosine of 0 plus c. Solving for c gives us 3 over 2. Therefore, the displacement is negative 3 over 2 cosine of 2t plus 3 over 2 meters. For part C, we need to find the total distance traveled from t equals 0 to t equals pi. For distance, we need to integrate the absolute value of velocity. Over this interval, sine of 2t is positive from 0 to pi over 2 and negative from pi over 2 to pi. Therefore, we split our integral into two parts. From 0 to pi over 2, we integrate 3 sine of 2t, and from pi over 2 to pi, we integrate negative 3 sine of 2t. When we evaluate these integrals and add them up, we get a total distance of 6 meters. And there we have it. We've found when the velocity first equals 0, derived an expression for displacement, and calculated the total distance traveled. This problem shows how calculus helps us analyze particle motion, and how the absolute value of velocity gives us actual distance traveled rather than just displacement.